In the domain of science and enormous secrets, the subject of what existed before the huge explosion has blended discussion and charmed personalities for quite a long time. This significant inquiry doesn't merely challenge how we understand the universe, it challenges the actual limits of human knowledge. Imagine standing at the edge of existence, staring into the vast darkness, and pondering what lay there before our universe was born. The moment of the Big Bang marked the dawn of mankind, space, and everything we know. Yet, was there a moment prior to this? Could there have been a state of nothingness, a silence before the cosmic symphony began? If so, what was it? Or perhaps something even more unsettling existed before time itself. As we delve deeper into this question, science takes us on a journey beyond the universe's origin, into ideas that defy our understanding. Physicist Brian Cox, known for his exploration of the wonders of the universe, proposes that something startling could have existed before the Big Bang. He challenges us to rethink our concept of reality and existence. In this exploration, we'll examine the science, the theories, and the astonishing secrets that could explain what existed prior to everything. We'll explore concepts like cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we uncover may astonish you, but they could also offer new insights into our place in the universe. Prepare to dive deep into a world beyond imagination. Science where the unknown still looms in the shadows, leaving researchers baffled and sometimes even unsettled. Let's explore what existed before the Big Bang and why these theories challenge everything we thought we knew. To understand what could have existed before the Big Bang, we first need to carefully examine what the Big Bang actually was. Scientists define the Big Bang as the moment when the universe became extraordinarily hot and dense, expanding rapidly to trigger the creation of all matter, energy, and cosmic forces. When we gaze up at the night sky, we see evidence of this hot beginning, with galaxies spreading out in every direction from a central point. But why did this happen? And was there a time before this dense, hot beginning? According to the theory of cosmic inflation, there indeed was a before, and it was far from empty or serene. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and stretched out, almost like a vast vacuum. However, this vacuum wasn't completely empty. It contained an immense amount of energy that powered the rapid expansion of space itself. This expansion, called inflation, occurred so quickly that it essentially set the stage for everything that followed in a fraction of a second. Space expanded at unimaginable speeds until the expansion slowed and the energy transformed into matter, particles, and the forces we recognize as the Big Bang. But what was the nature of this energy? Why did it suddenly expand the universe? And why did it stop? Scientists believe that this cosmic inflation created patches of the universe, each experiencing its own Big Bang. Imagine a fabric stretching endlessly with small bubbles forming here and there. Each bubble represents a universe, including our own. This concept, called the inflationary multiverse, implies that there are potentially infinite Big Bangs and an endless number of universes. Ours is just one of many. This vast, mind-bending reality challenges our understanding of the universe itself and leaves us with the question: what else is out there? The idea of nothingness before the Big Bang is theoretical, not literal, at least according to our current understanding. Even if you removed all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that create an unavoidable tapestry of something, even in its most barren form. Even if we imagine stripping away all these forces, leaving a dead emptiness, the universe would still generate new forms of energy. This fact alone confounds scientists, as it suggests that true nothingness might be impossible within our cosmic understanding. As we probe further, we discover that space itself has properties, rules, and constants that do not allow it to be completely void. Imagine creating a region with absolutely nothing in it. No particles, no radiation, no energy. Yet, quantum fields and fundamental constants would still exist, meaning that this nothingness has properties. For example, there's a phenomenon called zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can still momentarily appear and vanish, creating a ghostly echo of activity even in what should be empty space. This challenges our concept of a true void and suggests that even before the Big Bang, there was something, a faint, underlying presence that scientists are just beginning to understand. One of the most surprising theories in modern cosmology is the idea of eternal inflation. If inflation could make our universe exist, it's possible it could continue indefinitely. Brian Cox describes a staggeringly vast inflationary multiverse where universes are endlessly created and keep expanding. Imagine each Big Bang as a spark igniting a new universe, while inflation continues in other areas, creating countless other universes. This process could, in theory, go on forever. This idea of endless universes gives rise to a fascinating concept of a fractal universe, where each new universe has the potential to create its own Big Bang. Each universe exists as a separate, self-contained realm, unaffected by the others due to the rapid expansion of space. For scientists, this theory is both thrilling and unsettling, as it suggests an infinite multiverse with no ultimate beginning or end. What if our universe is just one speck in a giant cosmic structure, endlessly expanding and creating more? And what if the unsettling truth is that there is no before or after, but only an eternal cycle of universes forming and decaying? Our understanding of nothingness changes when we consider quantum field theory. According to this theory, the universe is not a collection of matter floating in space. Instead, it is a network of energy fields that fill the universe, interacting to create everything we observe. These fields are like invisible oceans, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they remain active. Particles can appear and vanish in these fields, borrowing energy temporarily before returning it. This phenomenon results in virtual particles, entities that briefly exist and then disappear, leaving behind a faint memory of their presence. The concept of virtual particles challenges the notion of a true void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have absolute nothingness? According to quantum field theory, you would not. Even in a vacuum, fields remain active, occasionally producing fleeting particles. This constant activity in what should be nothing suggests that the universe does not understand our concept of emptiness. The fields and forces persist, filling the universe with an intrinsic energy that prevents absolute nothingness. This understanding raises a fascinating question. If fields create particles, and particles create matter, could the universe itself have arisen from this nothingness filled with quantum fields? Dark energy is a mysterious force that currently drives the accelerated expansion of our universe. But did dark energy exist before the Big Bang? According to scientists, it's possible that the dark energy we observe today is a remnant of an energy field from before our universe's formation. Dark energy's properties seem to suggest a vast, hidden force that may have existed in some form prior to the Big Bang. Some theories propose that dark energy, in a much stronger state, may have powered the inflationary phase, allowing for rapid expansion. The presence of dark energy implies that even if our universe were emptied of all matter and radiation, this force would continue to expand the fabric of spacetime. This idea leads to an unsettling possibility. If dark energy existed before the Big Bang, it may have shaped the conditions that led to the birth of our universe. Could dark energy be the silent architect of cosmic inflation, or even the true origin of our universe? As we explore this possibility, we confront the potential of dark energy as not just a force shaping our universe, but also as a key that could unlock the mysteries of the multiverse itself. Another theory offering an alternative to the Big Bang as the ultimate beginning is cyclic cosmology. This idea suggests that the universe goes through cosmic cycles of birth, death, and rebirth. In this model, the Big Bang is not a one-time event but rather part of a cosmic rhythm, where universes expand, collapse, and then re-expand in a new cycle. This theory implies that our universe could have been reborn from the remnants of a previous universe. The process of contraction and expansion in a cyclic pattern means there was never a true beginning, but rather an infinite sequence of universes emerging, evolving, and renewing themselves over and over again. Cyclic cosmology raises profound questions about time itself, suggesting that time might be circular rather than linear. If this theory is correct, it could mean that what existed before the Big Bang was simply another version of the universe, one that collapsed only to give birth to our current universe. For scientists, this theory offers a rich solution to the question of an ultimate beginning by proposing that there isn't one. Instead, the universe has always existed in some form, transcending our concepts of time and existence. Primordial gravitational waves are another intriguing concept that could hold clues to what existed before the Big Bang. These waves, ripples in spacetime, could be remnants of the universe's earliest moments, offering insight into the nature of the cosmos before its current state. That happened before expansion and the hot, huge explosion. Anyway, finding early-stage waves from before the enormous detonation is a tremendous test. Researchers are creating delicate instruments to identify these unpretentious waves, trusting they will one day uncover a secret layer of inestimable history. Such a disclosure wouldn't just provide answers about our universe's outset, but also about the further grandiose forces that could have started its presence. Quantum froth, an idea proposed by physicist John Wheeler, is another hypothesis that hints at the chance of pre-huge explosion existence. According to quantum mechanics, space isn't genuinely empty but is filled with constant fluctuations of energy at the smallest scales. This quantum froth suggests that at the smallest sizes of existence, particles can appear and disappear in short-lived moments, leading to temporary bubbles of energy. This idea supports the vacuum beginning speculation, which posits that the universe may have arisen from an enormous quantum fluctuation in the ocean of quantum froth. The vacuum beginning theory suggests that what we see as the huge explosion would have actually been one of these energy fluctuations evolving until it became the universe. This view rethinks the concept of nothingness, suggesting that even in the absence of matter, energy, and traditional spacetime, a unique reality exists. If our universe is indeed the result of a fluctuation in quantum froth, then there might be other universes appearing and vanishing within this quantum ocean. This idea expands the multiverse hypothesis and proposes that our universe's existence might be far more common in the grand scheme of inestimable phenomena. Quantum burrowing is a phenomenon in quantum mechanics where particles can pass through energy barriers even when they don't seemingly have enough energy to do so. This concept becomes fascinating when applied to the universe itself. Some cosmologists suggest that our universe may have burrowed into reality from another aspect or realm. Quantum burrowing would allow energy to overcome otherwise insurmountable boundaries, resulting in a universe emerging from another plane of existence. This hypothesis adds a mysterious layer to what might have existed before the huge explosion, as it implies that our universe could have spilled or burrowed into being from a different domain. If this hypothesis holds any truth, our universe might be just one of many that form, evolve, and disappear within a much larger hidden structure. Quantum burrowing suggests that the huge explosion might not be the beginning, but rather the result of a boundary being crossed, a moment when our universe emerged into the vast unknown. As we explore these hypotheses, it's clear that our understanding of the universe's origins is limited yet evolving. The huge explosion was once considered the ultimate beginning, the specific point from which all existence sprang. But now, with ideas like inflation, the multiverse, and quantum fields, we see a much more complex tapestry. Scientists like Brian Cox urge us to imagine that something existed before our universe, something powerful enough to ignite the huge explosion and trigger the chain of events leading to our reality. The implications of these theories are both exciting and humbling, reminding us that the universe is filled with mysteries yet to be solved. So, what existed before the huge explosion? While science may one day reveal more answers, for now, we stand at the edge of what we know, looking into the unknown with curiosity, wonder, and a bit of fear. The vastness of the universe, its intricate designs, and the mysteries it holds remind us that our position in the universe is both unique and fleeting. Embracing this mystery is part of what makes us human and inspires us to keep exploring. As we continue to investigate the mysteries of what might have existed before the huge explosion, it's essential to consider the role of theoretical physics in shaping our understanding. While the concepts of quantum mechanics, inflation, and the multiverse provide compelling theories, they all highlight one key idea. The universe is far more complex than we initially imagined. The very concept of time, as we understand it, may not have existed before the huge explosion. In some interpretations of physics, particularly those related to quantum gravity and string theory, time is seen as a new property of the universe rather than an intrinsic characteristic of reality. If this is true, time itself may have emerged only when the conditions for space and matter were set in motion during the huge explosion. Before this moment, there may not have been a before at all. No sequence or progression, just a timeless state that defies human comprehension. Additionally, some cosmologists speculate that the very laws of physics, as we understand them, may not have applied before the huge explosion. In such a pre-universe state, the principles of causality, which govern how events unfold, might not have been in effect. This leads to the mind-bending possibility that the usual rules of cause and effect, which guide our perception of reality, could have been entirely different, or irrelevant, in this primordial state. In this view, the huge explosion may not be a singular, unique event but rather part of a continuous, cyclical process of cosmic evolution. This aligns with the idea of a big bounce, where the universe contracts into a singularity before expanding again. Such a theory offers a potential solution to the question of ultimate beginnings, suggesting that the universe's birth may have been preceded by an earlier cosmic contraction, leading to a perpetual cycle of birth, death, and rebirth. These ideas highlight the limits of human knowledge, but also emphasize how close we are to potentially uncovering a new chapter in our understanding of the universe. Every new discovery, whether through the detection of primordial gravitational waves, further exploration of quantum fields, or theoretical advances in string theory, may one day offer us insights into the nature of existence itself. The journey toward these answers may not be quick, but the pursuit remains one of the most exciting endeavors in science today.